Students, please, maybe you have to available here. Maybe guest is coming. That is no way means. Please come and join at YouTube.
Good morning, Principal Sir.
Good morning, sir. Good morning. Good morning.
Good morning.
Dear cadets, ask your friends to join faster. See, once this goes to count goes to 100, then you won't be able to. Your friends will not be able to enter inside. Then they have to go to the YouTube only. We have seen last 2 days. It has been a heavy rush, so it's overflowing. Now we have to be very careful on that. Kindly convey this to your friends.
Sir, Principal Sir. Sir, yesterday a list of faculty was taken to propose for a course. Uh, all the faculty will do the course at the same time, sir? Under
Sir, all faculties in your department having COC and the eligibility, definitely they have to do the course, sir.
Yes, sir. Now I am taking classes for nautical science also, conducting CAT 1, CAT 2, and semester
Yeah,
exams. Everything.
I think you have given the names, sir. I think you have given
Yes,
the
sir.
names. Is that
Given
right,
the
sir?
name. No, my question is,
Yeah,
everybody
fine,
will
sir,
do.
fine.
Everybody will do in one batch, sir. Online course, one batch.
No,
Or
no, no. That depends upon the management. They will come up with a balanced strategy, sir.
Okay, sir. Right. Okay.
Don't worry about. I will discuss on that little later, sir.
Okay, sir. Right. Right, sir. Okay.
Thank you. Good morning, sir. Welcome. Chief Engineer Rajan, sir. Welcome. Yes, sir. And Mr. Murugappan, sir. Welcome.
Hello, sir. Good morning, sir.
All in bright uniforms today.
Season.
சொல்லுப்பா.
Right, sir. Madam, I think you have 9 minutes to go.
சீஃப்க்கு இதை வெல்கம் கொடுங்க ஃபஸ்ட்டு. என்னது சாந்தி வந்து வெல்கம் கொஞ்ச நேரம் மட்டும் பண்ணுங்க, ஃபஸ்ட்டு செஷன் கிட்ட மட்டும். டாக்டர் சாந்தி மேடம். அதுக்கப்புறம் வந்து நான் வெல்கம் அட்ரஸ் கொடுத்ததுக்கப்புறம் முருகன் சாரை பற்றி நீங்கள் சொல்லிவிட்டு அவ்வளோதான். அதான் பிரின்ஸிபலுக்கு பேச சொல்லுங்கள். அது நம்ம அந்த பிரசிடென்ஷியல் அட்ரஸில் அந்த இதுவில் இருக்குமே, பிபிடி பாருங்க. இந்த இருங்க வரேன். பிபிடி ஓப்பன் பண்ணுறேன் இருப்பேன். பிரசிடென்ஷியல் அட்ரஸ் வந்து சசிலதா மேடம் ஃபஸ்ட்டு. ஃபெலிசிட்டேஷன் அட்ரஸ் தான் வந்து பூபதி சார். ஓகேவா? ஓகே. எல்லாம் ஸ்டூடெண்ட்ஸ் வராங்க. நாளைக்கு வந்து லிங்க்கை மாற்றினாங்க. சரி.
Good morning, Madam sir.
Good morning, sir. Students, please come under the YouTube. Staff is here, please.
Gokul and Durga Babu, please go to YouTube. Can you hear me, Durga Babu?
Yes, sir. Tell
Go
me,
to
sir.
YouTube. Gokul also, you go to YouTube.
Okay, sir. Thank you, sir.
Good morning, Murugappan.
Good morning, sir.
Bharati, Sundar, you also can go to YouTube. Gokul, can you hear me? Can you hear me, Gokul?
Yes, sir.
You can go to YouTube.
Okay, sir.
குட் மார்னிங் மேம். வாங்க மேம், உள்ள வரீங்களா? சரி, சரிங்க மேடம். ஓகே. ஆ ஆ ஆ ஓகே மேம். தேங்க்யூ மேடம். ஆ ஆ தேங்க்யூ.
Got it? Can you just go ahead now?
எஸ் சார். ஓகே சார்.
Yeah.
Shanti ma'am,
எஸ் சார். சார்
you start recording.
okay sir. That is ma'am is not yet concerned. Ma'am in another one meeting.
So still we have 2 more minutes. Shall we start right now or shall we wait
Yes,
for,
now you have to start one with Booba sir is available na.
Right, so fine, let us start.
Take, ask madam also, send a SMS to madam and ask them. Then it comes sharp.
Send the data from the ship to the shore, and this is going to be the panel where the controller is going to be feeding all the data to this equipment, This is called as an RCM equipment, where you can just see this GPS signal is there and WAN signal, and you can retrieve the data by the USB and any mean of connection to the computer also you can make it. So this controller is equipped in that way that all the data has to be sent in digital format or analog format to this equipment. Then that is being sent through an antenna to the satellite. Then it is being receiving to the shore, anywhere in the shore according to the access. The access is not provided, you cannot do anything, because some illegal practices can be happen. They can just directly change the temperature and the cargo can be damaged within 24 hours or 48 hours. So access is very important in this point of view. As we know, the containers are being the major part playing all over the world. Before days, the past, we are just having like 5, 10 containers, maximum 50 containers or 100 containers. Just before 10 years. Nowadays, they are carrying around 1,000 reefer containers and more than 1,500, which is not very easy for a ETO to just monitor all the reefer, whether it is maintaining in temperature or not, and the repair work also is to be carried out by the ETO. So the access should be given to the captain. So they will monitor, and even for the ETO has to be given with the proper responsibility. So they can view the different temperatures and the alarms from his cabin itself. Even though a physical inspection has to be done every day, at least one time. Normally we make it for 2 times a day. So for 1,000 and 1,500 containers is not very easy nowadays. So at least for one time we can make this application and software to be used by sitting in a cabin to have a look at all the parameters. And the alarm also is going to be triggered in the device. It is going to be implemented in that way. So that's all about this small advanced control in the monitoring of the containers, cargo temperature, and it actually is very important for the customers to know the shipment, if they maintaining it properly or not. Like all the data is being stored in the controller, but nowadays they are going to just view every few seconds what is the temperature is maintaining. That is a very important and it's very useful for the customers also. It's not about one container where the owner is going to have one container, but most of the operators are having a lot of containers, so it's very useful for the operators. And in the same reefer, we are having one more advanced control, which is going to be maintaining oxygen level inside the container, where normally any kind of food or leaves or any kind of stuff is going to liberate the CO2 content. That CO2 content will not allow the food substance to persist for a long time. So what they are doing is, the controller is connected with a vacuum system and a detector where the oxygen level is maintaining or not. So the oxygen and nitrogen is going to be intake inside the reefer container, and there is a membrane which is going to filter only the carbon dioxide with a vacuum pump. This works completely all the time. When there is no carbon dioxide, this system will be going to switch off. So switching on and switching off of this device is not happening by itself. The control system has to do it, right? So this kind of model is not going to work for all the reefer containers. It only practice over the star-cooled reefer containers. Only this model has been working as of my understanding. And super freezing containers are also being used nowadays. This super freezing containers you can see in the reefer itself, which can be maintained minus 20 degree to 60 degree, which is having 3 compressors and 3 evaporator fans and a condenser fans also. Sorry. Actually nowadays the COVID-19, everyone knows it's a very essential medicine which is required, has to be maintained in minus 70 degree. So transforming the medicine from other countries, the shipment has to be maintained in minus 70 degree all the time. If the temperature is going to reduce, the medicine is going to get damaged. And I just read an article that if the medicine is not going to maintain minus 70 and the temperature is going to rise, and it should not be used for any person, and it should not be cooled down again, it should not be used again for the person. So if it is being used, then it can be a major impact for the person who is injected with the high temperature of the medicine. So in this way, this is going to be very useful also. And every equipment what is there here are going to be controlled by the controller. So normally we have only one compressor and one evaporator and one condenser fan, which is going to have a normal method of running the equipment to cool down the system. But here this is going to be advanced, which is having many components to make the temperature, to reduce the temperature. Okay, we'll just go for another system. It is common for everywhere, but I'll just like to inform if some people doesn't knows about this. In the fire detection system, we're going to have a panel and all the sensors going to connect in a series, and the end sensor is going to have a resistant which is going to make as a complete loop. In this, what I would like to say is, if there is a fire in a ship and the smoke is detected, during the night time, the alarm will be indicated, but before you reach the location, it can make a huge fire. To avoid that, what the research is made, they can just connect one flame sensor, this is a flame sensor and one smoke sensor. If both the sensor is going to activate together, a fire is there and a smoke is there, then what will happen? The control is going to given to the auxiliary of the local firefighting system. This is the local firefighting system, which is having a separate pump and a motor with a separate solenoid. Actually, what is the use of the solenoid is to in which location the fire is happened, this solenoid will get energized by this controller. So it is going to put off the fire by using a sprinkler. We'll just see how it is going to put off. As we said, during the night time, if it has happened, if two fire sensors like a flame sensor and a smoke sensor is detected together, it will start to spray the sprinkler by the auxiliary contacts of the fire detection system to the local firefighting system. It is set in that way. So the major places where the fire could happen is the boiler, above the generator, above the main engine and incinerator and purifier room. These are the places we have an oil, we have an oxygen, and we have the heat material. So the possibility of getting fire is very easy. So the fire detection system is going to detect properly, and then that is going to activate the sprinkler to put off the fire. So without the human presence also, this is going to happen. So this also comes in the small part of the control system for the advanced control for the for the shipping industry. Actually, this system has been implemented very long back, but still it is in the modern ship. So I just want to inform. And the speed control of the motor. Actually, most of the seamen will be knowing about the speed control for the mooring winches. Normally, in the olden days, we used to operate the mooring winches with an hydraulic operating method, where the motor is there and the hydraulic system is going to operate the mooring winches. So the ropes are being sent for the tying of the ship to the jetty. Then later on, what happened? They are trying with another method, like pole changing method. The motor's pole can be changed using the contactors and the relay and timers. With a many number of poles, the motor speed is going to be very less speed. And when we are going to cut down the poles step by step, when you have a very less number of poles, the motor speed is going to be increased very high RPM. So that method was used during my third or fourth ship, but during my first ship it was an hydraulic system. I don't know what reason they are just shifting from one system to another. It is the advanced technology they are thinking, and they are trying to implement some good system from the drawbacks and safety related. They are trying to implement this kind of things. And nowadays they are controlling the motors using the variable frequency drive, where variable frequency drive will not allow the motor to start from the starting to the reaching of the rated RPM. It will not reach suddenly. We can control the RPM slowly by frequency controlling. And as we feed the AC supply, the filter, the capacitor is going to filter the noise signal and other interference. Then it is going to make a smooth DC circuit. Then that is being fed to an inverter, which is going to have no fluctuation with the motor or a noise in the power. So by that way, you are going to control the motor speed linearly. It is not like other pumps and motors, which is going to start with full load directly. It is not like that. So we are using this model in the mooring winches and also in the engine room ventilation fan. Actually, for the mooring winches, we will just finish it. This is having speed control sensors, and during the starting, we don't want to operate the ropes to run very fast to the jetty to tie the ship. It will be running in very less speed. Then depend on what requirement. If the wind is very high, they just want to put the motor speed very high speed. So in this way, the mooring winches ropes are being sent using a PLC system, which is deciding the motor is going to rotate and what is the tension of the rope. By the tension of the rope, automatically without the person inspection the rope tension, the PLC decides and it ties the ship's rope with a minimum and maximum tension without a person physical presence. So this kind of advanced systems are being implemented nowadays. Before days we just go directly to the controller and just tie the rope by the controller. But nowadays it is going to be tied the rope by itself. And what is the need for the person to stay there? It is good for the person to do another good jobs. Okay. Then we just see about the engine room ventilation fan motor. Nowadays motors which is supplying the air into the engine room and adjusting the air from the engine room or been controlling the speed by depending on the temperature of the engine room itself. Various locations will be having the temperature sensors which is going to be connected to the control panel of the engine room ventilation fans with a VFD control system that decides if the temperature is going to be very high, the motor has to be run the high RPM to supply the air or to exhaust the air from that location. And also for cooling down, if the temperature is very cold, we are going for the freezing location, the winter season of the Europe or Australia, what is the need for the engine to be make it very cold? Normally the engine has to be maintained in a very hot temperature to run for a good performance. So according to that need, and all the auxiliary equipment also required to be maintained in a particular temperature. It should not be maintained like 60 or 70 degree. In the Gulf area we get 60 or 70. That is not good for the equipment on the PCBs located in engine rooms. So they decided to run the engine room ventilation fan to maintain the temperature in the engine room. This is a small thing, but it implements many impacts inside the engine room. That controls a major part in this controlling of the motors. Okay, and we go for another topic like refrigeration leak system. We have in ship air conditioner system, provision system, and the galley we have the reefer freezers and the places where we store the refrigeration bottles. If anywhere there is a leakage during the night time or the person is not there, they have to know there is something wrong. The refrigeration gas. Similar in our room, our house we have AC. Mostly before we have R12 or R22 gases, which is very harmful for the human being. Nowadays they have stopped these gases, but still some places they are using this kind of gases, which is very dangerous for the ozone also. So when there is going to be the leakage of the freon, the sensor has to detect, right? So the sensor is going to, this is going to be the sensor and it detects the level of the leakage and that is going to be given an alarm. And alarm monitoring system is going to be given for the engineer rooms and they will be approaching to the location, and if there is possible to stop the leakage, they can do it. So this is just a part also for the control, how they are going to measure the leakage, and that is being controlled and monitored from the alarm monitoring system. Sorry. And we go for another system like overhead cranes. We have seen in industries and ships also. In ship, what they are doing in olden days, and just my my ship, which I was signing off very recently, was also having a remote control system like a cable, which is hanging from the moving part from the above till the remote control. This cable is getting twisted and twisted. If any grounding or any two cables are going to attach together, the control system is going to get short circuited or the contactor is going to activate, and without your knowledge, the crane can move to your starboard side or port side, or it can move the forward or aft, or it can heave up the material, or it can drop the material. So this kind of cables are getting damaged very frequently because of the improper use of the controllers. So nowadays, what they are doing in the new ships, they are implementing a remote control system which is going to work with the radio frequency signal, where the transmitter is going to be your remote control, and the receiver is going to be the place where is the moving parts. So by just pressing your button, similar like your remote control for the TV or AC, it's just going to operate what you need exactly. The transmitting of signal is going to be done from the antennas, and this process is being done through an designed microcontroller processor with a Zigbee, with the control switches. Without control switches on the relay, nothing is going to happen. So that is a major part, and with the processors, they are going to do this kind of wireless activities. Same, our children will be playing with a remote control car, right? It is going to be the same process, but the implementation in the ship, that is going to be very useful for the safety related and the fast operation. And I was facing many problems in the ship, like this control cable will get damaged anytime during night time and during the many shifting of the spare and the provision. I have to keep working for 2 or 3 hours. What is the required for working in this cable? Nowadays it is being controlled by a very easy method in the remote control system. So my job is going to be reduced also using advanced control with the radio frequency signal and the microprocessor which has been implemented. Okay, and then we just go for another topic, but this is going to be very useful also. Like normally container ships, which is going for the major cities, so the staying of in the port is going to be very less duration. So what they did in a few ports like Rotterdam and Jebel Ali. Actually, in Rotterdam, I have seen by myself when the ship is berthed, when I see a truck is moving by itself without a person, driver inside. All this operation is being carried out by a remote control system. The truck operates like a robot. It comes to the location near to the ship to discharge the container, and as well as for the loading it comes. And how this is being carried out? Some person is going to sit in their office, just play with the remote controller, and the truck is going to go very close to the ship. And even if two containers coming very close to each other, the sensor is going to detect that there is a possibility for accident, so it stops in particular distance. So by this process, if a human being is going to make a strike or some abnormal things like COVID-19, this robotic activity is going to be very useful for the port activities. Actually, this is not related to the ship, but still, this comes for the loading and discharging for the ship. If there is no activities carried in the port, then there is no activities going to carry in the ship also. The ship has to stay in the anchor. So the crane also, the loading and discharging crane also, I have just seen in Jebel Ali port carrying 4 containers at the same time with a sensor detects how to heave up the containers, and this loading and discharging of the containers also being done with an remote operation. Sometimes if the ship is not urgent in loading and discharging, they will just drop it as an automatic control, and they will just leave the location, and they can just stay in anywhere and they can just control by remote control or some software and applications. So by this way, the advanced control system is going to be very useful for the human being as well. Actually, I just thought of playing a video. I just try to find a video. You can just see this short video because it looks good, and I feel it's good to show you also. That's all from this video, and some of the control circuits which I have seen here. We have seen a lot of control system that is going to be implemented, and useful for the human. Main engine related of control system also, if time permits. Let us discuss very little fast. Actually, for the control system, we have control system in the main engine. One second, I think video is playing. We have seen for many systems how it is going to be helpful for the advanced control. Now we just see a few words about the main engine, how the control system is going to help with electronic and sensors and automation. This kind of things helpful when during unmanned ship, and nowadays autonomous ship is available also. I'm not going to brief more about the autonomous ship, but I'll just see the current situation. Actually, there is some ships already been sailing in the sea with an autonomous ship without human being, but which is not going to be work 100%, because a human effort should be there at least few percentage. Without that, accidents can happen, and possibilities of transportation of the shipment is going to be delayed. So they are trying also, and slowly they will be getting some information how it is going to be in the drawback sectors. So for running the main engine, you need to be kept in an unmanned ship where not all the ship is going to be kept in unmanned machinery spaces. During the night time, you just select a button and you go for a good sleep. And duty engineers will be getting the alarms. Only duty engineers are going to get an alarm. What kind of alarm is going to be displayed in this cabin itself, and what equipment is having a problem, and what kind of alarm, and what necessary action. It's not given what necessary action is to be taken, but you have to be present there in that location to know what are the problems and rectification that you have to carry. If it is going to be a small problem, then a person is required to solve the issues. If it is going to be a big issue, main engine is going to be stopped or slowed down, then he has to inform to the engineers or chief engineer, his superior. In that way, it has been for many systems like cargo handling, we spoke for the reefers, and auxiliary machineries, we spoke in last PPT. Now we will just see about the main engine related one. Actually, we spoke about the power of generation also, and ballast treatment also we have seen in last PPT. So we'll just concentrate only in the main engine. Okay, before past days, we just use a camshaft to give a fuel to the engine to run, and depending on the RPM of the engine, the camshaft moves clockwise or anti-clockwise. So by just removing this camshaft, we are going to replace with an electronic PCBs. So there is not any moving parts in the main engine nowadays. There could be a small parts, but still electronic is going to play a major role in the main engine nowadays to just give the fuel. As well as you can see, this is going to be the exhaust valve. Opening and closing is being done with the rocker arm before. Now this is going to be done with a PCB also, and major other sensor is also being connected to protect the engine itself, for the human safety and for the environmental safety. All this been come together with an electronic engine, and we'll just see a particular engine is called Wärtsilä Antiflux engine, which I was working for past 8 ships, and before I was working in a ship with a camshaft. Nowadays without electronic nothing is going to happen, so electronic based engine is very effective and troubleshooting is very easy, and also if some kind of troubles is very difficult to handle it, but the way of giving the trouble and the answers for the trouble, we will just see how it is going to be helpful for the engineers to make the solution very fast. We'll just see what are the components of the hydraulic system in a brief manner. I don't want to elaborate, it takes a very long duration to describe about this engine. For this engine, the major parts is going to be the electronic unit for each unit. Each unit is going to have a separate PCB, which is called as an FCM20, that is flex control module, which is going to control the activities of each unit separately. And also, each FCM electronic unit is going to be helpful for the communication from the bridge to the control room, and from control room to the engine control, and from control to the local control also. This PCB is going to be helpful, and all the sensor is going to be connected with this PCBs for the safety and control of the engine, but not other few sensors like of leakage or some other sensor which is not relevant to the safety and control. It is not linked with this PCBs. Okay, so what are the major components? We need a fuel, right? So we get the fuel to a supply unit, which is going to pressurize the fuel, and it is going to give for the unit. Before giving to the unit, what is happening, I will describe you in the next slide. And also a control oil, which is going to helpful for the control oil and servo oil, which is going to help for the pressurizing the exhaust valve. This is going to be the exhaust part. Okay, just opening and closing. What is the need of this exhaust? When the combustion is happening, the exhaust spindle has to be closed to make a combustion, to move the piston up and down. And when the exhaust is finished, the exhaust gas has to be sent outside to the funnel, right, to the manifold and then to the funnel. So this exhaust spindle is going to be open during that time. The opening and closing is going to be carried out by this pipe, which high pressure. So we'll just see what are the pipelines which is going to be carried out, what kind of oil, and how it is going to be useful. You can see this orange color pipe that is going to carry a fuel pressure. As we said, fuel supply pump, which is a mechanical pump, but carrying till this pump is going to be the electrical pump, where that is having a 2 standby pumps, and that is going to carry the pump fuel till this location. And this pump is going to work in a mechanical way. It pressurizes the fuel, and you can see the pressure is going to be 600 to 800 bar. This is very huge pressure. So measuring of this pressure is going to be done with a pressure transmitter, and that is going to be read in the control room. And if something is wrong with one sensor, the other sensor will take over. The control is given in that way. If both the sensor is going to be defective, the engine cannot be started at all unless it has been replaced. That is used for the control of this rail, this pipeline, to be maintained proper pressure. And we have normally a relief valve also, which just release the overpressure. And the similar way, the servo oil, which we said used for the exhaust opening and closing of the spindle, that is going to be 80 to 190 bar. Not similar to the fuel oil pressure, but still this is enough for opening and closing of the exhaust. And control oil also is helpful for the operating of the control oil. Is going to help in the pilot way of operating servo oil and fuel oil. It doesn't want to explain a lot about this control oil. Actually, this is the fuel supply pump which I was telling you. Actually, what are the electrical components and how it is going to be controlled? I'll just explain you. These are the separate individual pumps. We have around 6 pumps in this system, and each pump is going to have a separate temperature sensor. If the temperature is going to be less, it will intimate to the alarm monitoring system that this temperature of this particular pump is going to be less. How it can be less? If this pump is not going to operate, the temperature is going to be very less. It can be very high if something is really wrong with the mechanical parts inside the pump. So the temperature sensor, which is lying in the pipeline, going to give you an alarm and control the engine. If it is going to be very less, that is going to affect the engine control also. And in case of emergency, what happens from the bridge or the control room, if there is a huge fire in this location, example, you can directly shut down the engine by pressing the button in the control room or from the bridge, or you can activate this solenoid. Physically, you can just press this to shut down the engine. By pressing this, what happened? The complete pressure of the pipeline will be draining to 0. So, for maintenance purpose and also for the safety and also for the control, this solenoid, normally we have a solenoid in all kind of ships, but still, I'm just explaining you in this way it has been implemented in this model of the ship. And also if there is any leakage, there will be a sensor, flow sensor that detects the leakage. So without the automation, sensors like flow sensor, pressure sensor, temperature sensor, engine is not going to be operated. Measuring devices which helps in controlling and safety of the engine mechanical parts. This is the simplest way for the injecting of the fuel. As I said, this fuel is going to be coming from outside and it is being pressurized by a supply unit. Then it is given with the non-return valve where the fuel should not return back to the supply unit. Then it is being given to the fuel rail that is given for an ICU. What is an ICU? Injection Control Unit. How it is going to be helpful for giving for the each units? You can see the 3 lines. These are the 3 pipelines going to give the fuel for the each units to make the combustion. So how it is going to give a VEX controller. I said each unit is having a separate electronic devices, right? That is going to control a solenoid. This 3 is going to be a solenoid. This solenoid works depends on the flux control. And during the starting of the engine, these 3 solenoids will be energizing. So maximum fuel will be given for the combustion process. When the ship is going to run in the normal RPM, this flux view controller is going to just work only 2 solenoids, which reduce the consumption of the fuel, and this is enough for engine to run in a particular RPM. So when the ship is running in a very high RPM, all 3 solenoids will be working. That is being set with the program in the flux view electronic control. And every few seconds, when the ship is running in a rated RPM, I said 2 solenoids will be working, right? So how it is decided? This controller will decide every 20 minutes only 2 solenoids has to be working. After 20 minutes, the next 2 solenoids will be working. In that way, the cycle repeats. That is helpful to know from the computer whether the system is working properly or not also. So this is the same simplest way of explaining you the previous fuel system, which is having a lot of sensors, pressure sensors as I said you, and control, and actually actuators is there, which is a small governor motor. In previous older ships we have a bigger motor which is having governor motor, DC motor which is having brushes. Most of the time the brushes will be getting damaged or the moving parts sometimes get stuck. But this small equipment is very easy to replace. The actuators is going to be very small motors. It's not like a huge one. So this is being controlled by the electronic units. Each unit like FCM20 from 1. Actually with the engine which I was working is having 11 units. So like 1 to 4 it will be controlling the actuators motors to inject the fuel and reduce the fuel according to the RPM and the speed order given from the control from the bridge. Actually this is the system which I was telling, a solenoid that is going to be having ICU, and down below is going to be the pressurized pipe. So as I said the fuel is being sent through this way by energizing of this solenoid. So how this energizing is happening, there is a separate sensor near to this ICU injection unit, fuel quantity sensor. How much fuel is being sent into the engine is decided by this sensor, and the feedback is given to the electronic unit, and the speed is being controlled according to that. So by the feedback, the solenoids are being energized. And this is going to be the supply unit, which servo oil pipeline is going to be pressurized, where there are 6 pumps. This is going to be the pump, also mechanical pump, which is going to be pressurized as servo oil rail. Where here you are having a flow sensors. Each pump is having a flow sensor and actuator. Actuator is going to be a solenoid that is going to supply the oil into the pump to make pressurize. So each unit is having 2 sensors. So flow sensor, what is the importance of the flow sensor? If any one pump is not going to operate properly, this flow sensor is going to intimate there is a problem with the pump. So I could not pressurize the servo oil rail. So take some necessary action. So the pump can be replaced, or if the sensor is defective, it can be replaced. And one more thing, if any 2 pumps in this system is not going to be operational, still the engine can be running because the pressure for the servo oil is going to be maintained like 190 bar. If it is reduced less than 75 bar of pressure, then the engine could not be started. So we have to replace with 1 pump. So with other remaining pumps, it can be running. And how you will be knowing by physical checking, if the sensor, you cannot judge the sensor, by just touching the pump input and output, you will be knowing whether the pump is operating properly or not. So the sensor is going to be helpful, and the human presence also is going to be helpful. And this is the simplest way of servo oil pipe rail, which is going to pressurize, and the same way of the VCU, ICU, you have a solenoid, right? In the same for the servo oil also, you will be having only one solenoid, that is enough, because for fuel oil you are maintaining 700 bars, but for the servo oil it is only 200 bars, so one solenoid is enough, which is taking the control from the Fluxio Vex control. So that opens and closes the spindle of the exhaust to send the exhaust gas outside or to close for combustion process. And this is going to be a similar simplest way of for the servo oil, which is being taking the control from the unit 1 and 2 of the PCB. FCM21, unit 1 and unit 2 is going to be decided how much pressure is that. Then other electronic units are going to be connected in series, where all the electronic units are fed with a particular software, and all the parameters are being set inside. So if this 2 units is going to be get defective, the engine is not possible to start also. So the control system will stop the engine to avoid the accidents. And some other, as we spoke, control system is going to be the main part from bridge and engine room, and safety related and governor actuator is going to helpful, and alarm monitoring system is also going to helpful to monitor the situation. Okay. Safety system activities like slowdown and shutdown in case of the overspeed or other abnormal activities in the engine or its auxiliary equipment. We are just speaking about the main engine only, but still some other auxiliary equipment which is linked with the main engine also will be affected if there is something wrong. It can overpressure or it can make over temperature. So for this, all complete system is going to be connected with a bus communication system to the control room with the monitor. Before control room monitor, we are having an additional system. We'll just see about this system, which is helpful to troubleshoot the problems very easily. Before that, we'll just see 1 or 2 slides. Fuel leakage. By this fuel leakage, engine is not going to stop. Okay, fuel or servo oil leakage, the float sensor is going to detect, and we will see where is the exact leakage, and we will take a necessary action to stop the leakage. Okay, we'll just see an overview of PCB, how it is going to be connected the control room and the bridge. As I said, each unit is going to be connected with a separate unit of the main engine. In this, we are having only 6 units. So we'll just imagine we have a 6 unit of engine to be running, and we have an additional spare, online spare. What is the importance of this? If any one PCB is going to get defective, the engine will not be starting. So for replacing that PCB, you cannot just replace with a new FCM20 PCB. The one which is in the online spare, which is being connected with all the FCM20, is having the software and all the parameters which is common for all the unit is going to be feed into this unit, is ready, available to just replace with the defective one. And one PCB could not be replaced with another PCB, since that is being set for that particular unit. Because if, for example, we will see this one, propulsion control or from bridge control, that is being connected with PCB 1 and 2. So this is helpful for the communication from the bridge alone. 1 and 2 is helpful for the communication. Okay, alarm monitoring system. You can see the red line is passing to 3 and 4. Only 3 and 4 is helpful in communication for the alarm. If 3 is going to get some problem in communication, the 4 will help in giving the communication for the monitor in the control room. So in this way, each and every PCB is going to do his particular job as a separate role of doing his job. So, and maintaining the control on the safety of the engine also carried out by this way. And also the sensors like crank angle sensor, in what position the engine crank is located. So by that crank angle sensor, you are going to decide the firing order of the ship. We run in the ahead direction or to the astern direction, and as he spoke, servo oil pump is going to be helpful to maintain the exhaust and actuators for injecting the fuel and decide the reducing of the fuel. And also for the cylinder lubricating, we have a separate system. We'll just see now. Each and every unit is going to have a separate PCB that is going to decide how much lubrication is being done around the cylinder, where the piston is moving up and down, where the piston ring, if it is going to get damaged, lubrication is going to go down to the engine, the scavenge space. So lubrication, if any replacement of the piston on the cylinders, we can inject the lubrication more for that particular unit to make a proper lubrication. So this unit is also being connected with the FCM20. I think it is being connected with only one unit, like units cylinder 6. It is not connected with all. Yeah, it has been connected with all units. But all are going to be connected in the series. If any one is going to be defective, really the engine cannot start unless you troubleshoot the problem. If there is no proper lubrication in the moving parts of this piston, there can be a friction happen, then it can lead to a backfire, the blow pass, and it can make a huge accident inside the engine. It can explode the main engine also. So for that, we connect this kind of lubrication system for the control electronic system. We will just see what are the indication in the PCB, how it is going to show you the exact problem. As we said, there are 3 pipes going to inject for the fuel, injection 1, injection 2, injection 3. If there is a problem in the solenoid, particular solenoid, this light, LED light, is not going to indicate. So you can see the solenoid is defective, or the injector is choked, or the pipeline is having some problem. So by that, by just viewing the PCB, you can find out what is the exact problem. And the exhaust also, the moving of the spindle up and down, if this light is going to flicker, then that is going to be a normal operation. If this is not going to flicker, if it is going to be constantly lighting, then there is a problem in that particular unit. So starting also, you have a red light and yellow light. If the starting air has been sent inside for pushing down the piston to make a cranking effect, then it works in the yellow light. If starting is not being provided, it works in the red light, so we'll be knowing, okay, this is the problem, so we can directly go for this particular problem, and we will check whether the starting air is sent to a solenoid or not. If not, something is choked or something, we can just have a look. And similar way, there are many alarms. I don't want to elaborate all the alarms. Cranking angle sensor 1 and 2, there are 2 sensors, one is standby and one is going to be the master. You can change the sensor also. Every periodic duration you have to change it one by one to maintain it, whether it is working or not. And fuel quantity sensor, which is giving the feedback how much fuel is giving into the engine by the ICU unit. It has been given feedback, so accordingly the injection process has been done. So down below you have a power supply unit and module of this particular unit itself is working properly or not. We can view from this LED lamps. The CAN bus, it is going to be useful for the communication purpose from the bridge to the control room, and from the control room to the engine to the particular units and to the local control also. It is working properly or not, you can just by viewing in the each PCB, you can identify it very easily. And as we said, fuel is pressurized. We already set the fuel from the command from the bridge. It is going to be worked with a PI controller. It is going to be just a small PCB which decides the pressure and the current. By that, the command, the ship movement, RPM is going to be decided. This is a small way of explaining how the fuel and pressure and current is going to be implemented. Actually, fuel pressure set point is going to be set in the current value, and fuel pressure is going to be given in the pneumatic value. So both are going to be combined together with the PCB. That is going to decide the command, how much you have to run. You will just see some operation, how it is controlled from the control room itself. It doesn't want to go down to the engine. You can view all the parameters in the control room itself. You just see a few topics regarding this. As we know, all the sensors are being connected with one PCB. Actually, this PCB NAPEX is going to be connected in the control room, okay? Other units PCBs are going to be located in the local places of the main engine. So other units from unit 1 to unit 6 is being connected to the engine room, control room, apex, and that is being connected with a monitor and network, and printers can be connected, and alarm also connected to the alarm monitoring system. This system is going to differ from alarm monitoring system. This is only for the particularly for the main engine. If something goes wrong, that will give the alarm for the main alarm monitoring system that there is a problem in the main engine. But alarm monitoring system is having other all auxiliary equipments also can give the alarm. So the sensor in digital way or analog way, it is going to read the value, and the speed loads are all going to read in this electronic unit. And this is going to be the CAN bus, which is going to communicate from each and every PCBs. This is the image of the CAN bus. And I'll just explain you what are the parameters that you can view from the computer, the control room for the main engine alone. It is not going to be connected with any other auxiliary equipments. You can see the rail pressure, fuel rail pressure I was telling you, right? It is 800 bar. So if the engine is going to reduce the pressure, there is two sensors, 1 and 2. If one sensor is not going to work, it will intimate the alarm down below. This sensor 1 fuel is not working properly. So with other sensor, the engine can still work, but you have to resolve the problem for the other sensor. So control oil pressure also is being reading, servo oil pressure is reading, charging air. The engine has to be pressurized, so charging air is being reading. And the engine command, what command is given from the bridge is being reading. Engine RPM, what RPM is being given from the bridge is reading here. And injection process, it has been injection off time and frequency, sorry, fuel quantity, how much is being sent, all are being read here. Okay. And the number of nozzles, how much nozzles are used for injecting the fuel to the main engine can be viewed from here. And by easy way, the color coding, you can easily find what alarm is that. It is a passive alarm or critical alarm, or it is just an alarm for the rail unit alone. Depending on each color, you can find out is critical or major or minimum problem. For the normal start stop, you are going to have ordering of the speed, you are going to have it in the green. For the critical, you are going to have in the red. For the passive alarm, which can be solved anytime, that is given in the yellow. Like this way, you can easily find out the problem. And also, if any alarm is triggered, you can just right click from the computer in the control room to know what is the solution itself. So in that way, it will describe you what is the problem and what solution you can do, and where is a particular fault, you can rush to that particular fault without wasting the time. It describes all the possibilities of fault, but you have to read the manual carefully for what kind of fault, what kind of action has to be taken. It is electrical and mechanical related, so both the engineers and the ITO has to play a main role in this to solve the issues. Actually, in my career, I have faced a lot of problems in the Artiflex engine, which is very useful for me, and day by day I get a lot of problems. So I am getting a lot of experience in that way. Hope everyone also will be getting the same experience when you go on the board. And also you can change the values. As I said, your exhaust is going to open and close the piston. Sorry, not the piston, the spindle. Even the main engine is stopped, you can just directly press this particular unit. Which unit you need to open and close. After maintenance of the particular unit, you have to just confirm whether the exhaust is opening or closing. By changing the auto to manual, it can be changed to close or open. So just by clicking the button in the control room, you are going to operate the one particular unit's exhaust, which is very heavy to operate, but still it has been done from the control room itself. The same way, the blowers, as you know, the engine has to be pressurized with the blower. The starting and the stopping of the blower, if the engine is being running in a rated RPM, the blower will be starting and stopping in the critical RPM. If the engine is running in the less RPM, it will keep running. The blower motor will keep running to pressurize. If the engine is running in very high RPM, the engine pressurized by itself using a turbocharger. So to cut out and cut off the blower, we can just change the value from here. It is a pressure transmitter value. The pressure sensor is going to read the value from the main engine. By just changing the value from 0.2 to 0.45, the blower needs to be stopped. So this auxiliary control is being given to the blower control circuit. So by just changing the value, actually the transmitter is going to give the value here, and this is going to feed to the blower. You see the control system how it is playing with just a small change in changing the value in the computer, that is going to make a big change in the engine. This way, by the way, you can see the graph also. As we said, the exhaust opening and closing, how it is opening or closing. You can see the green graph is just fall down. It has not been opened properly. So you can know there is something wrong in the movement of the stroke moving up and down. So by this graph also you can see in the computer itself. You can decide what is the exact problem by this graph. Each and every graph should be nearly linear to each other. If there is going to be a big change, then that will give you a solution. This unit is having problem with the electrical or electronic or the mechanical part itself. This is going to be the injection for each unit. For each unit, the color is different colors, so it is showing how the fuel is being injected. And we spoke about the exhaust piston moving up and down, right? How is going to be set to on a computer in the control room? The sensor, the position sensor is, there are two position sensors, 1 and 2, for the safety purpose. If one is not going to work, the other one can still operate. If both are not going to work, the engine will directly shut down. If one is not going to work, the engine will slow down only. It will not reach the engine to run more than the rated critical RPM. Okay. So by this value, you can see 11.9 and 11.0. Mostly all the values should be equal. Actually, the sensor is going to read from 4 milliampere to 20 milliampere. By movement of this piston, it is going to read. If there is a big change in this value, then you can know this sensor is defective by knowing this one sensor or two sensor, which one is defective, or the piston moving up and down, maybe the carbon particle made this piston, the spindle to get stuck inside. This value will just directly give you the solution. So you can go to that particular place to know exact what is the problem. It can be the sensor or the loose connection of the sensor. So just by connecting it properly, it will be going to solve the issues. So similar way, you can actually this solenoid we were speaking about, the solenoid is working, so the fuel or the servo oil is going to be given to the engine, right, for the moving of the exhaust spindle. So this is having a timing also, microseconds. This is going to have a big change in the timing. Then the pulse given, actually the voltage given for the solenoid is going to be very less, like 5 voltage in AC circuit from the electronic PCB for each unit is given fed to the each solenoid. So if there is going to be a big change in the microseconds, then this activity of the solenoid is problem, or the electronic PCB giving signal to this is having a problem. So first you will go for the easiest part, which is which is easy to replace. So you will go for that one, and then you will go for the bigger part to know the way of prioritizing whether problem can be solved in the easy way or the difficult way. You can view from this parameters. As I said, the fuel quantity, the feedback from the fuel quantity sensor is being fed here. So you'll be knowing how much quantity is being sending to the units, and return all the fuel which is going into the unit is not going to be consumed, right? It has to return some fuel after using. So that has been viewed from this fuel quantity sensor. And as we spoke of the exhaust, also this fuel quantity solenoids also have a ICU. Actually, this complete unit is called an ICU. It is having a solenoids for return as well as for injection. This top one, this solenoids are going to be useful for the injection, and after using the fuel, the unwanted fuel has to be returned back, right? That is being taken to the tanks or to the line using this solenoids. So the parameters from this values, if there is going to be a big change, you can know what is the problem from solenoids or from injection injector itself. Injector is going to be a very fine, minute hole, which is very difficult to pass the liquid. By overheating of the fuel, it is very easy to transfer. So dirty particles can accumulate, so it will stop injecting also. That is also the possibilities. And now we can change the values. We just see by just selecting that unit, pressing the shift and the arrow button, you can change the value from run to cutout. The fuel can be cut out for particular unit. Even if there is a possibility for the unit to be shut out completely, the fuel, you can do it by just pressing a button, fuel cut, and the way of doing is shift and arrow and shift and enter. You can cut out one unit's fuel, and actually the fuel only has to be disconnected, where the lubricating oil for the near the piston has to be given all the time, so that should not be disconnected. So only the fuel is disconnected to avoid making the combustion process. By this way you can do it in the computer in the control room itself. No need to go down to close some valves. That is an olden way of doing it. And we already spoke about this. And also injection correction factor. How much percentage of fuel you require to send into the unit can be entered here. If the unit is replaced, cylinder, piston, and other parts are being replaced very new, then you don't inject 100% of fuel, and you can change it to 95% or sometimes if the unit is not injecting properly, the exhaust temperature is not going to be properly, then you can just inject little more fuel than 100%, like 105 or 110. You should not go beyond that limit, but there is a limit. It will be mentioned in the manual. You have to see the manual first, and then you have to change this value. If you need more, you can inject more than 100. If you need less, you can make it less than 100 also. And also for the cylinder, you can read the temperature. What is the temperature around the cylinder? If the piston ring is going to damage or the lubricating part near the cylinder is going to be not proper, that will give you the exact temperature, the friction temperature of the cylinder and the piston. So you can read it here. Actually, this will not give an alarm, as I understood. High friction. So it's giving the alarm in the flux, so it will be giving in the alarm monitoring also. Sorry, I did a mistake. Cylinder lubrication system. Yeah, okay. We'll just saw about the cylinder lubrication. This is going to be a cylinder circle where the piston moves in this location. Around this, you are going to inject the lubricating oil. How you are going to inject the lubricating oil? With a separate component that is going to be linked with a PCB, which I was telling. The separate unit is having a separate PCB, right? So it is called an FCM20 flux module control. Okay, this is going to be connected with that PCB. So you see, all are going to be interconnected. The control system is set in that way. If any one problem is happening in this place, the engine should not be started, or engine has to be slowed down. This way the engine is protected. Okay. You can see this spraying of the lubrication. We will see the next part. We will understand. The oil is going to be taken from this tank directly by a filter and is going to come in the gravity. Then it is being given to a component. As I said you, this is the component. It is going to be come till this location. Then it is being given to the cylinder. So how it is can be given? It is just coming by a gravity. It cannot go through the main engine by the gravity itself. So it has to be pressurized also. So how it is going to be pressurized? This is going to be that component which I was telling. The bottle. This is going to be a bottle which is pressurized for 30 bar nitrogen gas that helps in pushing the oil with 30 bar of pressure to the for the lubrication purpose. So you can see the lubricating oil inlet. This pipe is going to be connected for the lubricating oil, and this all 8 pipes. Since it is 8 pipe, because it is giving all around the cylinders, this 8 pipe is given the output. So how this is going to be controlled? This is having a separate 4 way solenoid valve and a pressure transmitter, pressure sensor, or it can be a pressure transmitter which reads the value, how much is the pressure. So solenoid energizing will not energize by itself. The electronic engine, each unit's PCB has to give the signal to energize this solenoid so that the injection is going to be given. And this pressure sensor is going to read pressure. If there is a less pressure which is injecting, then the sensor is defective or the signal given to the solenoid, the timing for the energizing the solenoid is not proper. So by this way you can approach the exact problem for avoiding damages. If any one of the unit is not going to inject the lubrication, the engine will never start at all. Actually there is a non-return valve in this location somewhere, maybe here could be. One non-return valve was not working in one of my ship. That stopped the ship, which doesn't allow the engine to start at all. It triggers an alarm and safety to stop directly the engine. It cannot start at all. So this unit has to be working for all the units. Even if you want to switch off the fuel for the particular unit, the lubricating system has to be working all the time.
Sir, excuse me, sir. Murugan, sir.
Yes, madam.
Next guest, Sundarajan, sir, also waiting, sir, more than half.
Okay, madam. Just give me 2 minutes. It's already finished. Almost
Okay.
finished.
Okay, sir. Thank you.
And as I said, the flow sensors are going to detect. You can see this is the sensor which is not moving parts. It is going to just work in the capacitor way. 2 plates are separated between a distance. If oil or any abnormal substance is going to flow in between this location, electrolyte, it is going to disturb the plates in between, capacitive effect. So that is going to detect and give this alarm in the alarm monitoring system. So you will be knowing which part the fuel or the lubricating oil is leaking, so you can troubleshoot it. You can see before this we used to see the float means it just move up and down to activate the operation. Now it is going to be a not movable one. And this all way you can just troubleshoot the problem. Each and every alarm you can be seeing in the manual or in the FlexView computer itself in the control room. Each and every alarm is going to display here, and the alarm's solution can be given here. So you can go to the particular problem, and solving is very easy. So this is the troubleshooting manuals. And thank you very much. As time is short, so I cannot explain a lot about the main engine. These are the main important systems which is controlling the advance in the control system in day-by-day life, and it is not going to stop at all. Day by day they are going to innovatively thinking, and they are trying to get new advanced systems which is going to be very useful for the human being and the safety in the ship at sea. And that's all from my end, and thank you very much to all faculties and HOD and principal and to the organization. And thank you very much for listening my good
Thank
skill
you,
which
sir.
I
Next,
Thank
next
you,
one
sir.
day,
Thank you for your
very.
valuable speech. And Shanti madam, please wait.
Okay.
Thank you. Thank you, sir, for your valuable inputs. And you have taken throughout the ship. You have explained all the electronic items, right from funnel to tunnel and forward to arm, port to starboard. No doubt. Sir, in fact, when it comes to electrical and electronics, there is another program also on 4th and 5th in the evening around, I think 5th and 6th in the evening around 4 to 6, I think, conducted by Triple E, madam. I would like to make that announcement also. Kindly, cadets, all of them, please participate in that. It speaks about the power electronics and so on. So, which is very essential on board a ship now. Now, I hand over the mic. The time is very short. I'm handing over the mic to our Dr. Sundarajan sir, GME HOD, and above all, placement coordinator. I tell you, sir has built 3 ships. It's not an ordinary thing to just sit down with an architect and, execute the field jobs. And sir has been a superintendent. Sir has got vast experience in the latest technologies, and you are seeing his inputs in our placement activities. So the mic is yours, sir. Please go ahead, sir. Thank you very much, sir. We welcome Dr. Soundarajan, sir, for the panel. Thank you.
Welcome, sir. Ari, sir, excuse me. Sir.
Yeah, tell me, ma'am. Sir, Shall we proceed with the introduction or let him take the session, sir?
Sir, give an introduction which you have written.
Okay, fine, sir. Fine. So, thank you, Murugan sir. Now it is time to introduce our second guest, who is none other than Chief Engineer Soundarajan sir. He has 35 plus years of vast experience as a marine engineer. He has exclusively worked in the dry dock of vessels, and he has completed his Class 1 Chief Engineer at AMC Australia. Now, being an energetic and devoted engineer, he is willing to accept all the project management positions or whatever the positions that suits his career in any maritime organization to pursue with and to bring some innovations in that. And he has a strong technical and analytical skills, and he's a good learner too, and he is an excellent communicator too. And he is very likely to take many important positions in reputed organizations also. Now, with this small introduction, I would like to hand over the session to Chief Engineer Sundarajan sir.
Thank you, sir. Welcome, sir.
Welcome, sir. Sir, you're muted, sir. You're muted. Mic is muted.
Good morning, one and all. Thank you for
Good
this
morning, sir.
opportunity. Good morning. Thanks to the principal, to the management, and colleagues and my co-chief engineers, the seafarers, non-seafarers present here. You could have visualized in the earlier speech by Mr. Murugan. He has gone through the engine in and out electronically. To be frank with you, having served for 35 plus years, plus 5 years here and there, with overall of 40 experience, and I could say that we are still learning. The learning factor doesn't stop. If we have to pass the knowledge throughout as a marine engineer, I must have sailed for 2000 years. I mean, it has to have that much of experience. Each chief engineer who are here, who were all experienced, they experienced the different products, different aspects, different ships, different approaches. Now I could understand from Mr. Murugan, though I have sailed about 25 or 30 years earlier, I could understand what is the development of the main engine is. So is the case for the propulsion also, which I have been asked to render few of the topics with respect to the modern propulsion and how it has been under the evaluation, long history of the propulsion, and what is the present situation and scenario. I tell you, it takes a long time for us to express, but to bring it in within the forum of 1 hour, it's extremely difficult to understand, but we have to tell. Now I am sandwiched between the great scholars, great professionals like chief engineers and seafarers and non-seafarers, doctors of different industry here itself, and as well as our students. I cannot draw a line where I have to stop in, where I may go exit somewhere, I may go overloading the cadets also, but I request the cadets, if it is a little bit beyond also, do not worry. We have our own session when we are discussing, we can discuss so many things like that. So let me go to the topic, what has been assigned to me. Prior to that, I am thankful to the management, all the things, and such programs are eminent, are essential. It will be very fruitful for the future, especially in the name of faculty development. I cannot concisely say it is a faculty development is development for one and all, non-seafarers, seafarers, students, chief engineers even. That's what I'm trying to tell Mr. Murugan's speech was put me a little bit of a setback to say if I am given a job as a chief engineer on board after 15 years of survey, after 16 years ashore as a superintendent, senior superintendent, technical manager, retired as a general manager, technical, I would be really have to go back to the school to learn what is the current situation. Everything is automatic. Everything is electronics now. And I would definitely believe there will be some courses for even for the chief engineer to learn the modern techniques. Such persons like Murugan can be of handy in future. Right, let me go to my part of the topic, that is advanced propulsion. Before going that, let me tell you, my first ship up outside, I was going from Turkey something, it was a coal carrier, not coal-fired boiler ships, which 99% of the present chief engineers would not have even come across with that. First was the coal-fired boiler ship. That was like locomotive engines. Then switched over to heavy fuel oil. Then from there, Supermax, Aftermax, Panamax, Suezmax, then VLCC, then ULCC, like all fired by HFO. Then boilers. Then comes to steam propulsion. Then they developed into gas-fired boilers. Then the IC engines. Then comes slowly they have developed. And I tell you, today's this thing is beyond everything. And within 5 years, we can definitely see a drastic change in the propulsion itself. I myself have applied for something to formulate with Voigt Schneider, German company, to come up with latest some of these propulsions, but I could not continue, which I would like to say some few words when I'm going through this lecture. Right, sir. I would like to go through my sharing the screen. Please confirm whether you can see the screen. Any one of you, please, for my sake.
Yes, sir. Okay, sir.
Right. Hope you can see my screen, sir.
Yes, sir.
Is that clear?
Yes, sir. Yes, sir.
Right. Thank you very much, madam. Thank you very much. And right. To be frank with you, you can see this here. This much is the material which I have collected from my file to talk about the advanced propulsion, which will take me few days instead of few hours, not even that 1 hour, right? But still, I will try to compress all these things, try to explain what is the present trend and future. All right, boy. All right, because I used to take the classes. I'm always remembering my students in the first place, right? So my address to the people of the audience here may be in the similar way. Excuse me if I have to use some of the words like that, because I've been acquainted towards that. The propulsion, the future advanced propulsions, without telling what is in the back, I can't talk about the future propulsions. Now, I have given here the types of propulsion is diesel propulsion, wind propulsion, nuclear propulsion, gas turbine propulsion, fuel cell propulsion, biodiesel fuel propulsion, solar propulsion, steam turbine propulsion, which was there earlier, which was later converted into LNGs. LNG, this thing, and it was surviving for some more time. Diesel electric propulsion, water jet propulsion, gas fuel or tri-fuel propulsion. These are the ways where the propulsion has gone through a long way. I hope I'm audible, madam. Hello?
Yes, sir. Yes, sir.
Hello?
Yes, sir.
Yeah,
Audible,
okay.
sir.
So I would like to brief some of these propulsion which has been there, which is in existence and it is going to be in the future, as I have explained. And before that, in between, I would like to introduce some of the videos which you can understand how the propulsions have been developing, all these things. And especially nowadays we are talking about this engine, electronic engine, that engine and all things is going to go off. Everything is going to go off with a simple mechanism. And if you could see, okay, before going to that, if you could see here, there's a shaft in there, there's a propeller, and I believe you can see this, madam, here, and you can see there is an engine here, there is a reduction gear, there are bearings, seals, propeller, and all these things are going to go off. Straight away, we are going to go in such a way that there is be no engine like that, there will be no reduction gear, there is no loss of shaft, there is no loss of power like DHP, SSP, DHP, THP and all. We are going to go straight into the propeller. How it is possible? How it is possible, you can ask, and that is what is going on nowadays. There is no diesel engine, there is not going to be steam engines, there is not going to be GT engines, gas turbines like that. So these are what I wanted to explain you all before, and I'm going back to that this thing. I'll come back here. So what earlier, we have been, there was a sail propulsion by sailing all this thing in 19th century. Then before that it was a human propulsion. The propulsion includes rowing, which was even in the large, very, very long days. Then thereafter sail propulsion has started in the 19th century, and later the mechanical propulsion. In the mechanical propulsion, we are still in there, and there is going to be an electronic type of propulsion in future days. In this mechanical, where we are currently now, these ships will go for another 10 days, 10 years or something. If we can see what all the propulsions involved, it is beyond everybody who can think of, right? So in that we have got many specialized variations such as contra-rotating propulsion, that is called CRP. It's called CRP, nozzle propulsions, single propulsions. All these things are coming into factor. Now if you can see, these are the propulsions: impeller, wave pulse fins, steam engines have mostly been replaced by the two-stroke engines, later the four-stroke diesel engines, outboard motors, the gas turbines, faster ships, nuclear reactors, steam turbines, again the nuclear are operated by the steam, used for the warships and icebreakers, and there have been attempts to utilize them for the power commercial vessels, which we can see in later stage. Right? Principle of marine pollution has gone a long way, which which is not necessary now. I told you these are the things which will be going after later date, which is not going to be extinct, which is going to be extinct. There will be no propulsions like this anymore. There will be no shafting also. All will be an electrical controlled propellers, which we'll also see that, right? So the propulsion system using the forces here and there, and the propulsion system is on ships can be enumerated as diesel propulsion, as I told you before. That there are implications in that. It has started when I have started in 1980s. I was throughout in steamships, and including the world's largest ship, Sea Giant and COIS Giant, which I'll show you there. And those sort of ships, which is about 5,65,000 and above 5,00,000 dead weight. Those are the steamships, and later the ships was given to a diesel-driven ships. Even on the diesel-driven ships, the fuel technology has improved. Then because due to NOx and SOx emission, they changed slightly into better way of propulsion using the marine fuels, varying the fuels, like dual fuel engine and tri-fuel engines. So we have all these things which have come across, which is there. Now I wanted to go in general. This is what is the secondary method, selective catalytic reduction, all this thing, that is for the exhaust control. Here the ship, which is there, which is the diesel, and you can see the gearbox, and it is attached to the ship. It is a simple mechanism, diesel propulsion, right? So we have, I have put some for the cadets, I put some advantages and disadvantages for them to know, as if they will be studying in future. And I wanted to go into step by step wind propulsion. Have you ever heard of wind propulsion Flettner rotor? This is the Flettner rotor, which has got no power at all, using the wind. Flettner rotor propulsion, if you can see here, I think I have here Flettner rotor. I'll come back to that when I have it here. I'll show you that. That shape. Yeah, I'll show you a little later. The Flettner rotor using the wind power, and it is on the sails like that, and it is kept on the deck, and because of the force and all, I'll show you that. It's very nice to look into here. When I'm looking into here, I'll show you this, exactly the Flettner propulsion here. Right. Before that, I would like to go into another propulsion. I'll show you that. Then I'll go to, it's called water jet propulsion. The operation principle of water jet propulsion is that water is drawn through the ducting. In olden ships, VLCC and all, we used to have a scoop system. Even the chief engineer who were working in that ship, GT Damawand, I believe. We have a scoop system where the water is being drawn in through the internal pumps, adding energy, and the water is expelled off at a high velocity. This is what is happening. I can show you that on a picture, on a video, right? Can you, if you can, madam, can you see this video here for me?
Yes, sir. Yes, sir.
Yeah, this is the water jet propulsion. You can see here, you got it's an axial flow pump. It is called axial flow pump. The water has been sucked like a scooping method, and it has been delivered under the high pressure. And you can see how best it is the thing which is the modularized interceptor, easy to retrofit, and this everything removed, no shafting, no turbines, everything has been removed here. All right, and you can see the nozzles here. Water jet is pushed through the nozzle, and the reaction force, the ship will be moving forward, the thrust will be happening in the aft, and the nozzle moving port and starboard, and a cap will be there which is to go for the astern movement. You can see how it is. This is called the water jet propulsion. You can see the nozzle turning from port to starboard side, and if I wanted to be the same flow, if I wanted to go astern, put down the nozzles down, either to turn the ship to left or right. This is called water jet propulsion. Many of the ships, passenger ships nowadays, they are going to use this sort of, because there is no noise, there is no pollution, there is no noise, and they are going to use the water jet propulsion for the ferries and cruise, and this is going to be the smoothest way, and this is going to give you about 25 to 30 knot speed also. Is that clear? Yeah. Okay, right. Here, this is one of the propulsion, and another one which is called paddle propulsion. This is called the paddle propulsion. Is also there, and you can see on the right hand side you can see the joystick where we can move. When I'm moving ahead, the motion is in the forward. The thrust is created by the paddle by pushing the water aft. This is like a fish pushing the fins, and you can see the thrust, and the motion is in the opposite side. When I'm putting it astern, the thrust is going to be in the forward, and the motion is going to be in the aft. That is how the blades are moving. It is called paddle propulsion. This one is a paddle propulsion. This is also is going to have an enormous effect on the tugs and everything in future. All right. Then we can see another type of propulsion here, which is called contra propulsion. Means with the same shaft, you can see double in two direction. This propulsion is going to be the future. It is called CRP, contra rotating propulsion. I'll show you another video, another PPT, so that we can understand what is CRP is about and SSP is about. SSP another one. All right. So these are the things which everybody should understand, and this is the one which is the latest one, which is called azipod propulsion or azimuth propulsion. Azimuth propulsion is going to give a 360 degrees turning. There is no rudder. There is no main engine. Okay, we can get inside. We can get inside even the engine and using the electrical power. You can see this is powered like this, very efficient, and the best part of it that we can interchange within hours. We can change the whole assembly, get it outside, go for the AMC. They will come and fit it up and they will go off. This chip, we have one chip like that in with us, the research chip in Goa, and we have used this one. Now you can see this. This is called azipod, and you can see this shape, the shaft and all. You can see the internally there is a motor there, which you can see how best the modification has taken place, and there is no rudder, there is no engine. Now when you look at this, wait a bit, I'll make I like to show this to the boys, to the cadets here. All right.
Okay, sir.
Yes. Here, when you happen to see here, this is where the people can come inside. The people can come inside. Here is a motor, and that is here the motor is fitted, and it is the powerful cable is going to come inside. When the cable is coming inside, right, and that is going to go. The cables are coming inside and feeding this three cable. All the cables are coming and running a motor here, and that will be the power. That will be the driving media for these propellers. For these propellers here, there are three, and you can see that the changing. That is called azimuth. They are called azipod propulsions. Okay, when you see it here, you can see it clearly, azipod propulsion. All right, I will show you another one. Okay, can you see that here? Here, this is called azimuth. Now you watch that it is going to turn 360 degrees. There is no rudder, and it is under the CPP system. It can be the pitch can be turned. With this is the future of the propulsion system, azipod system. You can see that clearly, right? The whole assembly is turning like a turret. And you've got the fins back. This is called azipod propulsion. That is, we can have 2 or 3 depending on the size of the ship. And what is the beauty of that? When you happen to go to the dry dock, one set is already ready there. You just knock it off. Everything, other one is put within 1.5 days. We have the engine ready. That is the beauty. All dry docking is going to be with respect to the engine, with respect to the rudder, with respect to the propeller, with respect to the stern tube, all removed, stern tube, all the things are removed. This is going to be the future, and all the things are going to be, all the repairs are in a way, it is replaced rather. It's like a spare part taken from the unit, one will come, same one will be fitted, and they'll take the old one and they will do this. And this is coming from 3 companies, Alstom, Shuttle, and Siemens. They are making like this, and this is the future of the propulsion, which is called azipod propulsion. Is that clear, sir? All right. Right. We will. I would like to go through some of the slides here. Right. This is what I have told you about the water jet propulsion. This is the transmission of propellers here. Right. This is the CRP system, which is called contra rotating propeller. You can see 2 propellers and the shaft are there. This is another understanding, it is to recover the slip stream rotational energy forward of the propeller. Okay, we can, I don't want to go into deep into all those things. Just if you can see the figure, if you see the picture, you can understand how the systems are working. Yeah, I'm just going ahead with this contra rotating gear system propeller or CRP propeller. Propellers, this is the one, CRP 1, 2, these are different drives we have, and the CRP Z drive is here, and the modern contra rotating propellers are like this, grim wheel propulsions are like this. All these things are the future propulsion, which is totally eliminating all the full functioning of the future propulsion. All right, this is called nozzle propulsion, where the water is being guided to the propeller, and that is going to create a very good thrust in this. Now you can see how the nozzle propulsion, you can see the plus and where the pluses are there. You can see very well how the thrust is going to happen. Bulbous bow, the stern and all will have the similar way to have the thrust motion to move the ship, to turn the ship very faster. This is also there. This is called the nozzle propulsion with the equalizing duct, right? So let me go into another system of this thing. Whenever I'm coming, these are the skewed propeller, which is plus 6% of efficiency, more 6%. Thrust free net propulsion. This is also a fixed CPP system, where it can have a develop structural changes in this, and the pitch can be changed. And also the beauty is that it is going to give you the speed with which nobody has suspected. As the trains are coming in the oars with bullet trains, these are the propellers which are going to increase the speed of the ships, future ships. All right. So the electrical propulsion is going to take place in future. This is what the acetate propulsion. This is called podded propulsion, and this is the history and the advantages, current stages, and all future possibilities, which we will explain at a later stage. Right. In 1990, a development was taken place in power electronics and capable of handling the load and frequency various better. QT first model on passenger ship to go in this sort of propulsion. 95 megawatt power stations have been using it. 120 megawatt can be entrusted in this. A smaller motor, higher motor efficiency, higher power conversion efficiency, reduced motor maintenance. All these things are added advantage with this azimuth propulsions. Right. Okay. All right. Now let me. I will go only with the figures, because there is a lot of explanation to do on all these things. Madam, can you see this, man, please?
Yes, sir. Yes,
Hello?
sir. Yes, sir.
I will stop in anyway. Bring lower load. All right. So, yeah. So these are the shaft thing, which is no more there, which I will come back to you on the other one, which is called these are called the screw propulsions, which blade of gravitations and all, and which is not going to be there anymore. And we will see another one, which is giving you the tidal. Yeah. We got so much to talk about, but unfortunately each will take a day or for the explanation. I wanted to cover so much for the boys to see what all the propulsions are available. Then we can talk about in details. This is called Mermaid All-Storm propulsion. This is also in the picture now. This is called 14 megawatt elation propulsion. Sir, you can see that, please. Hello? it is going to reduce the turning circle so much. And you got now here. Here you can see the exact, as I was telling you, you can go inside Azipod section and you can see how you can enter. This is the modern propulsion. You got the motor and all. When you see here, when you see this picture here, you can understand how this is there. Can you see this here, sir? A man can go inside the propeller. That is the electrical part of it. There is no rudder, there is no shafting, there is no engine. And it can create up to 30 megawatt power cross section of a pod. The electrical motor is placed in the pod. The screwing bearing makes the pod 360 degrees rotational. Look at the man inside to show approximately the size of the pod. This is the future propulsion. All right, sir. So what I'm trying to emphasize here, there are so many propulsions like this, which we are going to, which will be seen by the cadet in future, and we will. This is what I have made it when 2013 or some project FTPS, one of the ship which I have made for the which I have prepared for the White Schneider German companies, right? This is the world largest ship which I have served. Here we can see how we can improve the efficiency using the turbines, fixing the blades on future propulsions, tidal power, using the tidal power. This is what is exactly required. How the energy has, this is another ship which is there, which is called FTPS, which can produce current. That is floating terminal power station, which I have termed it. There is another ship which I have designed was FFPT. That's a future one to give the petrol station on any sea here. This is the typical white turbine on board a vessel, and you can see these are the turbines which are all there. And in future, if the ship is stationed, we can produce current using the underwater current, which is called turbine. Turbulence subject for the power for production. We don't have to do anything. Everything will be taken care of, because this tidal power is 10 times more powerful than the wind turbines. All right. So you can see here. You can see here how we can design. What all the ways we can design using the turbine rotors here, which is different turbine rotors, and already in existence. There are so many underwater 1,200 megawatt to 1,320 megawatt is been built in Incheon, South Korean. This thing, all these things are there. In that Gujarat, we have planned. I was in the team to plan underwater turbine also to produce the current, and we were having the meeting also. So the propulsion is going on in a very vast, very fast region, very fast way, and that is what we are expecting it to be. And this is where the meeting with Mr. Goel, and we are producing we are interested to do tidal current ships. Now you can see the Golar, the turbines, which maximizing the power generation of FTPS. These are going to be the future propulsion. This is the power which you are getting from the waves also. So different types of propulsions are there, which we can discuss in the later time when we are having the renewable energy. All right, sir. Then I want to. This is the sailing which we have taken place in the first, and the nuclear propulsion is this, and you can see it is similar. It is similar to the steam turbine, right? When you happen to see here. Here is the turbine, which is called HP turbine, and the main turbine here, and here you have the nuclear station. This is where the nuclear power, this thing is taking place, and this is the clutch where we have, and on all the electrical power which has been produced is also here, electrical propulsion motor. All right, and this is the pressurized water naval nuclear propulsion system. This is the also the future propulsion system. All right, sir. Here. So we have got this. What are the advantages? Nuclear propulsion during the operation emits no CO2, NOx or SOx, volatile, all organic, and practicable emissions. Then we got so much advantages like this here. Disadvantage, and we go back to the gas turbine propulsion. Gas turbine propulsion is also similar to here. This is what is been used on aeroplanes, and this was the one which is going to give us the power in future. And this is the gas turbine. This is the combustion chamber here. The compressed air is here. Here exactly, to be precise. You can see there are 3 sections here. Yeah, and this is the 3 sections are here, and the center one is called combustion section. This is the turbine section, and same to that, which is a high speed. You've got a helical gears, and it has been transmitted to the propeller here. These are the systems, and the HP and the LP turbines are here. The gases goes inside, again recirculated. This is called gas turbine ships, which can also come into play when actual hydrocarbons, which are fossil fuels, which is called crude oil, which is raw and which is not matured enough to give. So we are converting that into a matured fuel like HFO and MGO or MDO. Those things are going to go away because lots of fossil fuels are no more, will not be there for in another 1 or 2 decades. What we have to go in the gas, and this is the one of the system in the engine which we will be applying such technology using these gas turbines also. All right. All right, going back to this, again, radiant seal 9 megawatt, and this is the ASI pod. This is the one which is being supplied, which will be coming in a compact one. They will come inside to the dry dock, they will replace it, take the old one, and like an AMC, next time when you go, it will be there. So it reduces so much factor. We don't have to use any spare, we don't have to put any spare, we don't have to worry about anything, just supply the current, and that's it. This is the way they are going to go ahead. And SSP stands for Shortened Siemens Propulsion System. Shortened Siemens Propulsion System, and this is all the things are the features of that. Steering gear plate. Here it is in the steering room that is going to be rotating in an aspect to say that, and it is going to rotate at 360 degrees using like a turret of a crane. This is the thing. And here is the electrical propulsion, which is going to replace, which I have been telling very frequently. Right, this is the dolphin type. Another azipod propulsion. This is another backup power. Also, it is also an electrical powered propulsion. Okay, we've got so much propulsions ahead, and they are going to look into that. Now, hybrid CRP. CRP stands for contra rotation. That the opposite direction it is going to rotate. This is called CRP propulsion. There will be two propellers involved in this. All right. Okay. Let me go to another one of the slide, because I am trying to show as much as possible so that boys can understand what is there. I'm not going to go so deep in everything, just to catch up here and there, so that when they want, we can go everything step by step in a deep manner. That we'll see that in the next class, or whenever they wanted to know about the future propulsion. Now, as if whatever we are covering is good enough for them to know what are the types of propulsion available, what are the advancement it is available, it is enough. And a guy like Murugan is going to play a very good part in this sort of propulsion. That is what I would like to emphasize at this juncture. I'm going to conclude in another 10 minutes time, not even 10 minutes, just to tell you.
No, sir, continuing, sir. Thank you, sir.
What happened?
Yes, yeah. Sir, you take extra 10 minutes, sir. No problem, sir. Thank you.
Okay, I do not know whether I'm going beyond the limit, or I'm telling for the student, or I'm telling for the other people. But so much of materials are there, so much of effort, future proportions are there. It is not going to be concluded in such a short period of time. But I would like to express maximum. Yeah, hello. Yeah, can I? I can't hear anybody. Hello, sir. Anybody?
No, sir, no, sir. Continuing, sir. Thank you, sir.
Somebody wanted to talk about. Yeah, no problem. Now you can see here conventional and ASCII part. Which all the things are removed here? Earlier one, we have a rudder, we have shaft, we have engine, we have propeller, we have stern tube. Now look at this ASCII part. What we have is nothing but a propeller hood where we can get inside, only supplying the power. This is going to be the future propulsion, and everybody is going to work electronically. I have got 10 such PPTs to talk about the electrical propulsion, but I do not know whether that will be of useful at this stage for the cadet. So let us wait and see how they are understanding in future, how their ships are going to be powered. You can see this is called Siemens and Shuttle. Shuttle is a Germany. Siemens is also German ASCII part propulsion. ABB and Kroner, these are in the market now. Alstom and Rolls-Royce, Dolphin, STM, these are the manufacturers for the future propulsion system. All right, and AC and the small, then we can see this. That's a control CRP propulsion here. All right, so we'll talk about something more in the other slides. Now this is the Grimm wheel, another site of propulsion, and this is the modern contra-rotating propellers. You can see two or three contra-rotating propellers. It's going to give you a very, very technical high advantages, and this will help to maneuver and reducing the turning circle to drastic to the very, very level. It will turn so fast that you cannot imagine. We can avoid accidents and all. All right. So this is the one, and let me show you another. Here, when we have to design, when I have to do for a propeller design, this is what I'm planning for our college, to have a test bed and to increase the research knowledge of the cadets, to have a hull, ship hull called the open water test, and the dynamometer, where we can design our results. That's why I wanted to show maximum today to the cadets, so that you get into the future propulsion, get into the research mode of application. It is not that everybody has to go to ship and work. You can work here and you can learn multiple times of the seafarers, provided if you put your research mind in this. This sort of test beds, this is what we are prepared whenever we design a propeller, whenever we have some, this is the tank here. See, the smallest comparison scale propeller has been used here. Then we will see how much the thrust is prepared, how much, what you are putting, all this contra propulsion, azimuth propulsion, everything is done in the test bed like this. You can watch it up, how this sort of mechanism is going to work for the future cadets here, how we are going to go ahead with the future propulsion system and the research system for the cadet, and how MTA can play a part in the research. And why not our Amet students one day can design our own. That is what every faculty of ours has to improve, to bring such a knowledge to the cadets, to prove how good we can, and we can have our own propulsion system. That is what we can do. Many research in this connection, and that's why I wanted to show you this test bed also. so that everybody now we can understand what is going to be the thrust, weight, and everything we can calculate in this, and by using the different sensors, like, right, this is the sensor point. We know how much the thrust is created. By this we know all this. This is going to be, and I wish we will have in another 2 MTIs. We have this. This is the 1 MTI where I studied. I brought it here to show our cadets, and I also to implement. I will request such this thing research facilities will improvise and take our students to the next level and be prepared for the future propulsion system. All right. Then I hope I explained about the water jet, and and here and another SCANA's propulsion system. Just watch this one. That is called CRP Contra rotating propellers. See how it is, and the shaft in the independent. See that 2 shafts are opposite direction. How they have built it up, and how the prime mover is acting, how the high power density and the unique efficiency is given by the electrical motor in a single shaft, how the 2 propellers are interconnected, but though they are 2 shafts rotating in a opposite clockwise and anti-clockwise direction, see the pitch of the propeller is differing, and thus is going to have an added advantage, and this way is going to give you lots and lots of energy and lots and lot of thrust, and we can expect very high. Even we are very big ships can go in a little longer, better speeds and all. This is called contra rotating propellers, and this is called contra rotating propulsion systems, right? Robust in components, redundant in solution, efficient in system, and this is what Alstom company is working, and one of the branch is already in Chennai near Palavra. They are also working at this, making that sort of things. I wish our cadet also participate. This is the one which I showed you before, and then I'm going to use this one. All right. These are the future turbine and propulsion system where in the FPSO, FSRU, FSU, FFPT, FPO, FSU, all these ships, FLNG, we can use this sort of mechanism to produce power by sitting there using this sort of turbines, underwater turbine, and thereby ruling out the power constraint on board that ship. This is what has been a new development which we have made 2-3 years before. All right, and here the project FTPS, as I told you before, which I've shown you also, and we have commercial viability also have been calculated, right? And this is the waves, and this is the turbine. For the wind turbines, you can see this is not a huge turbine, and it is not going to be a big issue for them to install on the wind, and the power, all the FTPS can power thousands of navigation lights here. This is what the aim for the future navigation also. We can have the scrap vessel of a passenger vessel to convert into a hotel. This is also possible using such turbines to produce huge amount of power. It is not that I am telling it is going to be future, and there are so much of power system already being executed with this sort of turbines and all. All right. So you can see how much megawatt power is being drawn using this sort of turbines and propulsions, which will be of greater advantage in future marine industry. All right. Then I would like to show something. Here. So, like not this one, 118. Electrical propulsion. So this is the power I have shown you. One more thing I wanted to show here. That is the advantages of another propulsion here. You can see this here. What is that? What is that power here? The motor, electrical energy, brake system, everything is confined to a small area here. And this is the future, and you can see how the power is going to come from. And the 3 or 4 diesel engines, the power is going to come through the center, and we have got propellers on either side. They are operated with the Azipod controlled pitch propeller system. This is what the future propulsion system, and this going to give a lot of energy also. And you can see, as you can see here, see that this is the fans and everything. This is how a single steering plate on the SSP, that is called shuttle propulsion system. And here, these are the things how they are changing this motor on the dry dock, right? This is the electrical propulsion, and the back now the power, etc. here, right? Impeller, omni thrusters. This is the new injection system. Water jet propulsion, as I told you already. This is the, here you can see the axial flow, like a scoop system. Whenever you might have seen in a ULCC or VLCC, we are going to draw. When the ship is sailing, we are going to draw the water by the scooping system. Whenever we are going in a speed, we will stop the motor for the cooling system. By the scoop itself, it is going to cool the condenser. Similar to that, by scooping, this axial flow pump is going to create enormous thrust, and that thrust is being converted into a nozzle, and that is going to give the power which is jetting through the stern of the ship, providing the thrust. And this water jet propulsion is going to be enforced for all the cruise ships as well as the ferrying boats. This is added advantage because no pollution, no noise, no turbines, no engine, only except to run a pump which is below the ship under the water. This is what the water jet propulsion here in clearly stating how it is, how the pump is going to work, how it is being driven by a simple motor, electrical motor, and this is the scoop method, the intake grid, everything is here. Okay, you can see clearly. If you can see clearly, everything is here. The pump is there. This is called axial flow pump. There is no suction head. There is no discharge head. Just taking the water from the sea, thrusting it out, and that is how it is going to operate. And I showed you this water jet propelled. The same thing is here. The same thing is here, and how the nozzle is going to turn the ship port and starboard, how it is going to go astern. It is a simple mechanism, and this is if we put 3 or 4, and it can drive a ship of 60,000-70,000 tonner also. This is the another way of giving a luxury propulsion system for the cruise ships here and there. And you can see how they are turning also. This is called the buckets. Buckets are being kept, and it can be operated by the actuated drives, and this is the system of propulsion which is called water jet propulsion will be used, and this will maneuver in the same location within a very small basin. We can turn the ship excellently. If this would have been there, you should not have had this Suez Canal accident also. Like this sort of propulsion will be of great help, and this can be used in shallow waters also. In the shallow waters also, that is what the shallow water propulsion is about, and this is what I wanted to explain. There are about few more electrical propulsion, which I don't know where did I put that material there.